right? And I'll try to assist you. So if you go to the tutorial folder, it says there that in week 12 and week 13, that same assignment task will be a tutorial, right? Okay, so we are doing this a bit early so that you don't put things to the last minute, and you can get this assignment out of the way. All right, so if you want, you can download this, okay, and save a copy. And to really help you with your assignment, it is very much directly related. You have notes, okay, PowerPoint notes, which was prepared by one of our former lecturers, Dr. David Etchison. And you will find this under this here, chapter 6, mechanical engineering drawings, right? So, okay, if you click on the lecture notes, the flange coupling PowerPoint slides, so it goes through the step-by-step process, okay? This engineering assignment 2 again is a design problem, okay? And we'll go over what you need to do and what you need to deliver in terms of your calculations and your drawings, right? So keep this with you while attempting the assignment. So what I have done is put everything in a folder for you guys. I mean, this is for my sake. So the first one is the coupling design, okay, which is here. It's about the winch design, and itself we have the assignment 2 in PDF form. Let me just push it here. Right, that's the question itself. Okay, and the other thing you need to download is the calculation sheet, right? So meaning you will be doing your calculations here. Okay, and push this here, enable editing. Right, I'll come to this later on. So let's look at the question itself, right? So you might think it's very complicated or it's very bulky, but see, if all you need to understand in terms of what you need to deliver is the deliverables, right? Okay, so there are two parts to this. The first part is to do all the calculations, okay? And in those calculations, you have to show some analysis, right? So these are the key analysis. What happened?
Hello, is anyone there?
Is it you, Joel?
Yes, sir.
I thought something happened and it got logged out or something.
Okay.
Connection dropped. Okay. Uh, let's see what's going on. Let's see how many of you are here still. Eight of you. Set. Okay, so if you are, again, if you wanna just know briefly what is going on or what you need to be writing or drawing, okay? So for the calculation part, you need to do all this analysis, which is the key analysis and the hub analysis, the flange, as well as the bolt analysis, right? And again, all the calculations and sort of like the formulas and the steps you need to take for all the analysis is given in this PowerPoint, right? Okay, and once you do all your analysis and all your calculations are in place, then you will use those values. So let's say, for example, in the key analysis, you'll know what is the dimension of the key, length, width, and the height, and you'll generate the drawing of the key in AutoCAD, right? As for the hub, you're measuring the hub thickness, okay, or the hub height. Once you know all that info, you will be generating drawings for the hub, okay, as for the flange as well, and the bolt as well, right? Okay, so that's how it works. First, you do your calculations, get all your dimensions and your measurements in, then you use those dimensions to generate your drawings, okay? Right, so far so good. Everybody on the same page? Okay, I'll just pause for a while. If you have any questions, then do ask me. Okay, so let's start from the top, right? Okay, so okay, it says that the first part, you know, as part of your engineering design process, it's about identifying the problem. So here, what you are given as your problem identification or your problem definition is that you have been approached by a local company who wants them to design a key inline key drive shaft. Key drive shaft means this. Okay, let me just show you a picture. Okay, here. Oh goodness. So that there, okay, in dark gray, that is a key, right? Okay, so you have a shaft, and on top you have a key, right? So that's what it is referring to. Okay, so the flange coupling is to be used. Okay, so what will the flange coupling? Okay, flange, this is a flange, as you can see in figure 1. Coupling meaning two, right? Okay, so why do we need to? We'll come to that in a short while. So the flange coupling is to be used in a heavy duty winch application and consequently must allow the driving torque, right, to be transmitted from a drive motor to a gearbox. So what is happening is, let me see if I can get a drawing. No, 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 no. Yeah. Okay. So this pretty much explains, right? So on the left-hand side, you have a drive motor, right? So when you turn on the motor, it will start to spin at a particular speed, okay, or at a particular revolution, okay. And then what happens is, okay, it will generate power, and that and as a so when a torque is generated on the shaft, okay, it will turn, okay. Torque is the turning force, okay, the turning effect. So you want to transmit that torque which is generated on the side of the, what you call, the drive motor, and you want to transfer the torque to the gearbox side, right? So you have two shaft. One, the left hand, let's assume the left hand shaft is connected to the drive motor, and the right hand shaft is connected to the gearbox. Okay, so the gearbox shaft is stationary. Now you want to design a flange coupling so that the two are connected together, right? So the flange coupling is like a connector between the two shafts, right? So now when you turn on the motor, the shaft starts to rotate, which is connected to the motor. And once you design your flange coupling, then the flange coupling will rotate. And on the other side, with the flange coupling is also holding another shaft, which is connected to the gearbox, okay? So the power will be transmitted from the shaft, which is on the motor, to the flange coupling, and then to the shaft which is connected to the gearbox. Okay, so there it goes, right? So that's how it works. Okay, I hope you got that, right? We'll just keep this part here. Okay, so the design task overview. Okay, so the main factors which influence the design are listed below, right? Okay, so to transmit 75 kilowatts at 25 revolutions per second using 48 millimeter diameter shafting. Now, the first dimension you're made aware of is that these shafts here, okay, let me see. Okay, so the shaft will have a diameter of 48 mm, right? Now the flanges are to be made of cast iron and keyed to the shaft, and power is transmitted from one flange to the other by circle of fitted bolts. So the way you see here in this figure 1, that there are holes on the uh, flange. Okay, these are for fitting in bolts. Okay, so the two flanges can connect together, right? Okay, and the rest of the informations are given in relation to the bolts. Okay, it's ultimate tensile stress and the yield stress, right? Okay, so there are two parts to the design task. As I said before, number one is the analysis part. Okay, get all the dimensions in. Number two is the drawing generation, where you'll be generating all the drawings, right? Okay. So before I start with this, I'll give you some guidelines, or not guidelines, but I'll just get you started with your calculation report, right? So that things become much easier for you. And for the deliverables, it says you'll be using a calculation report, which means this one, the Word document, right? So you can start this by giving your project a name. In this case, it is a design of a flanged shaft coupling for, what is it for a heavy duty, right? Okay. So as for the author, you will write your name. In my case, I will write Sandeep. Okay, followed by my ID. Right. So you can probably write the date which you started the assignment in. Now this will be your page 1. Okay, right. And the rest of the pages will be pages 2, 3. So it depends how many pages you will use for the calculations, right? So I will write here page 1 of,
Yes, sir.
yeah, yeah.
So we can also include our partner's name as well because it is a group assignment.
Really, again, it's a group 1.
Yeah.
Ah, you lucky guys. Yes, yes. Okay, so similar to assignment 1, do include, okay, your partner's name or your group member's name with his and or her ID as well. Okay, got that? All
Yes,
right,
sir.
set. That's awesome. Okay, what's the first thing? Okay, so once again, let's start with the brief description here, right? So we'll start with the overview. So, okay, now this is your first time you're drawing up a calculation report. So we'll try to keep it simple, right? But here, so once again, so whoever picks up this report, he or she should know, okay, that, okay, this is what is going to be in this report, okay, and these are the calculations which I expect to find in this report done by these particular authors. And at the end, if that person is, let's say, working in as part of a manufacturing company, he or she should be able to use all your calculations to be able to physically manufacture that particular winch. Okay, so we are trying to keep it realistic. Okay, so we'll first start with the overview. So you can choose a particular type of font, right? So be neat about your report, okay, and be consistent, right? So in my case, I'm using a heading, so I'll just maybe underline this. I will say overview, right? Okay, and maybe I'll just delete this. Right. Right. So can you confirm if you're able to see my screen?
Yes, sir.
Right. Okay, so overview, right? You do not need to copy me, right? So overview is, in your overview is like a summary, okay? What information is provided here, right? And what you are trying to achieve in this calculation report, right? So you can probably write that, what have you understood so far? Okay, then I would say that this report documents, okay, you could say documents or contains or includes, so this document, this report includes the analysis, okay, we are doing analysis, and you could say calculations and assumptions. See, again, this is a design question, so there are some of the things, some of the factors or some of the key sort of numbers which you will be assuming. Okay, so do keep that in mind. So, and you'll have to list down the assumptions here. So, and assumptions used in the design of a flanged coupling, okay, to transmit. Okay, so how much power is this particular drive motor generating? Okay, from whatever we have gathered so far. Anyone?
75 kilowatt.
Okay, it will be 75 kilowatt, right? So I've just what you call, made aware by Zoom that we have another 10 minutes, right? So probably I'll try to extend this after it's over in 10 minutes, right? So if you want, you can stick around. If not, you're free to log off. So what else? Okay, so 75 kilowatts. Okay, so make sure you're consistent with the units, kilowatts of power at now. Once you turn on the drive motor, how fast will the shaft rotate, which is connected to the drive motor? Any idea? Read subheading 2.0. How fast will it rotate? It is given there as 25 revolutions per second. Okay, through a 48 mm. So you know the diameter of the shaft is 48 mm. Diameter shaft. Okay. Now this is really brief. Okay, you can add more information which you find in the question itself. Right. So what is the purpose of the coupling here? So you could also add that the coupling is to connect and it says here coupling is to connect a, what says, a drive motor. Connect a drive motor to a gearbox in a heavy duty winch application. Right. So that is my overview. Okay, and the next thing you can add is assumptions. Right. And we would say the assumptions you are making is that there are, in this case, it will be that there are no impact loads. Right. So what is the only source of load which will be acting on the, or what is the only type of the load which will be acting on the flange which you will be designing? Any ideas, any suggestions? Feel free to speak, right? Then I would be able to know that you are virtually present in this session.
So the torque provided by the driver.
Okay, so the only source of the load here is nothing else, okay, except the torque, right? So torque which is provided exactly by the drive motor, okay? So as soon as you turn on the drive motor, it starts to rotate at 25 revolutions per second, okay? It is constantly rotating at that speed, okay? And it is generating 75 kilowatts of power, okay? So that torque you'll have to transfer to the gearbox, Okay, and the connector which you're designing is a flange, right? Flange coupling. Okay, and at the same time you also have to list down the materials which you have used. So again, bold and underline. So you will make another heading, say materials used. Okay, so the first one is shaft. Okay, so as for the shaft, do you know do you know the dimension of the shaft?
Yes.
Yes, it's given as 48 mm, right? So in this case, you could say that no calculations required as dimension has been specified. Okay, again repeating myself, there is no need to write exactly what I have written. Okay, this is your assignment. Okay, feel free to write in your own words and from whatever you are able to understand in regards to this assignment, right? What's the next thing? Okay, let's move on to the coupling now. Okay, now as for the coupling, is it written anywhere? Okay, so the information is again, if you go to that subheading 1, okay, that's 1, problem and definition, and subheading 2 is design task overview. If you read this, you will be able to find out, and I would like to know from you what material is the coupling expected to be manufactured out of. Come on, there's 9 of
So
you.
is it the cast iron? No?
Yes, it is the cast iron, right? Okay, it looks like only one person is present. How about the others? Okay, I'd like to hear from you as well. Right. Okay. Now, if you read here, I'll just point it out to you. So it says here the flanges are to be made out of cast iron. Sorry. So you will write cast iron. Now, okay. For cast iron, what we need to do is we need to list down what is the for cast iron. We need to list down what is its tensile working stress and what is its compressive working stress and what is the shear working stress, right? So these 3 values. So your assignment question is 4 pages long, so just quickly skim through it and see if you're able to pick it out, the stress values. Somewhere here, given the stress values are given here. Okay, so the stress values, so for cast iron, right, the tension, which is the tensile working stress, okay, and the compressive working stress and the shear working stress values are provided here, right? So you can include them in your calculation report. So it's make sure you include them with the units as well, right? So in this case, it will be 8. So we will just, I'll probably end by 3 o'clock, right? So where were we? I just finished, I want to try and finish using all the materials which we are using in this, right? Okay, so as I said, for cast iron, you need to list down the stress working values, okay? Tensile, the compressive, and the shear values, okay? So if you, this is on page 3. Yes, it is on page 3, right at the top, okay? So for cast iron, the tensile value is 8, okay? Be consistent with the units. If you are using meganewtons per meter squared, then use it entirely throughout your report. If you're using Newton per millimeter squared, then do likewise. Okay, so it's 8 Newton. In my case, I'll be going with 8 newtons per millimeter squared. Okay, so that. And as for the compressive working stress, it is 45. And for shear working stress, the value is 5. Okay, do include the units. Right, and the next bit of information you will add is for the key, right? Okay. Oops. So, are you able to find anywhere in your assignment question what the key is supposed to be made out from, or what material the key is supposed to be made out of? Does it say anywhere in your report? Doesn't, right? So, see, but in fact, the key is supposed to be made out of steel. Right, now you'll do the same thing for the key. You will find the tensile, compressive, and the shear working stress values. Right. Okay, and again for steel, it's given as 35, 35, 28. Right, so this is supposed to be 35, 35, and 28. Right, and the last thing to add is see, not the key but the bolts. Right, now see, if you go to a hardware store, you don't have to really manufacture the bolts. The bolts, they come pre-fabricated. They follow some particular, either they follow the metric or the imperial standard, right? So okay, so in this case it has been specified on page 1. If you look at the information provided here, right, so it says the adapted bolt must comply to the following specifications, right? So property class, so in this case the bolts are supposed to be grade 4.6, okay, as stated here, right? And for the bolt, you will need to first figure out its the uh, ultimate tensile stress, and suppose it is given here, right? The ultimate tensile stress is given as 400, right, megapascals, and so that is 400 megapascals is pretty much mega Newton per meter squared, right? Okay. And for the bolt as well, you have to find what is the yield stress. The yield stress, this is given as, the yield stress is given as, yeah, 200 megapascals. So this is supposed to be 200 mega Newton per meter squared. And there are two other information which you require for the bolt, which is the tensile working stress as well as the shear working stress, right? Okay. There you go. Okay, these two values. Right, and the way you will find the tensile working stress and the shear working stress for the bolts is if you go to page number 3 at the bottom, right? So we are after the tensile and the shear, right? Okay, so it says here, okay, this note 1, okay, right? So if you look at the second paragraph of note 1, it says that the allowable shear strength of a steel fastener is about 0.66 times the tensile yield strength. Okay, so in our case, okay, so it says here 0.66 multiplied by the tensile yield strength. So we know the tensile yield stress is given as 200. So it's not 200. It's supposed to be how much?
240.
240. Yes, my bad. It's 240. Right. So if you read, if I just go back to this statement once more, so it says that the allowable shear stress of a steel fastener is about 0.66 multiplied by the tensile yield stress. So in our case, the the yield stress is 240. Okay, so 240 multiply by 0.66, that will give you the shear working stress value, right? Okay, and similarly for the tensile, allowable tensile, see, there is two things, there's ultimate and there is allowable. So when we say allowable, I got to check here. Yeah, I got it. So yes, this is Nitendran. Okay, he corrected us all. Good. Right. There is allowable and there is ultimate. Right. Okay, so we are looking at the allowable values here. So allowable and working, they mean the same thing, right? There's the working stress and there's the ultimate stress, right? So what happens is the working stress, they account for the factor of safety, right? So the tensile working stress or the allowable tensile So similarly, the allowable tensile strength of a bolt under steady loading is typically 0.66 multiplied by the minimum tensile yield strength. Right. So again, in our case, it will be 240 multiplied by 0.66. So in both places, it will be just 240 multiplied by 0.66. Whatever is the answer, you just note it down here. Again, just reminding you to be consistent with your units, right? Okay, it really does help. So in my case, I've used Newton per meter squared, and I then went with the Newton per meter squared, okay? So be consistent. So all this pretty much sums up your the important information which you have gathered from the assignment question itself or the assignment brief itself and included in the calculation report, right? So you are pretty much done with the first part, which is brief description. Okay, so we have included it. So brief description of design. So this included the materials used, the assumptions, as well as the overview. Now we will start with our analysis. Okay. So my question to you guys would be, right, okay, let's see if I can just get you guys working. I have 5 minutes left, so I'll try to wrap things up now. Okay, so, and in any case, if you need any clarifications, if I was not clear enough, please go through these notes, right? It teaches you or it shows you what working stress is, what the ultimate stress is, right? Okay, and how do we include the factor of safety to calculate the working stress, right? And always remember that the working stress will be less than or should be less than the yield stress divided by the factor of safety. Okay, so just to give you an example, if you walk into an elevator, it will say maximum 6 people allowed, right? So maximum 6 people or 1000 kgs. So what happens when it reaches that 1000 kg? If you load up that elevator to 1000 kg of mass, and then it starts to beep or it won't work, okay, the doors won't close. So that can be regarded as the working limit for the elevator. Now it doesn't mean if it goes up, if you add let's say another 100 kgs or make it 1000 and 1100 kg, it doesn't mean that the elevator will break, okay, or it will disintegrate. No, doesn't happen. Well, it might the elevator might break apart if you load it up to 10,000 kg, okay. So engineers, what do? Is they set a working stress limit, or they set a working limit which is far less than the ultimate limit, okay, the ultimate stress limit, because they do know. Why do they do that? Is to account for the factor of safety, right? Okay, so by mistake, if somebody loads up the elevator to 2000 kg, it still won't break, right? Because the factor of safety is included in their design, right? So that's what factor of safety and that what working stress and working limits is about. Okay, so now the next bit for you guys to do is just get you started. Times Roman. Okay. So let's see what is this? Torque calculation. Okay. So now we talked about that there is 75 kilowatts of power being outputted by the drive shaft, and the shaft will rotate at 25 revolutions per second. Okay, the shaft has a diameter of 48 mm. Using all that information, okay, and these nodes here, okay, determine how much torque is generated. Okay, so torque is a function of force times the radius. Okay, I have given you all the figures, and the formula is provided to you as well. Okay, so See, what I'd like you to do is include this in your report. So your report will be, just like if you read a textbook, it has the formula there, and then it has the uh, explanation of what each term means, right? So if you write the formula here, P is equal to 2 pi nt over 60, where P is the power, N is the rotational speed, T is the torque, okay? So you write it as such, and then below this, you do your calculations, okay? On the same calculation sheet, you do your calculations, and at the end, when you find the value of the torque, then you write that the torque generated at the input shaft is so and so Newton meter, okay? Right. So do not stress yourself much. Okay, I've got you started with your assignment. Now, the first thing I'd like you to do is the torque calculation, right? Okay, use this particular slide. This is slide number 15. The power is given. You know the power, yes. Again, if you are consistent with the units, you'll get your answer straight away. It's a very straightforward calculation. Right, power is given. 2 pi is a constant. N, what is N? N is the rotational speed. Yes, you know that. T is the torque. That is what you're trying to find. So make T the subject of the formula and divided by 60. So you'll be able to find the torque, right? After finding the torque, so if you like to soldier ahead, so then you have to determine the key length. Okay, so this is the key here, right? So determine the key length. So you will notice that all the formulas used, they include torque in the calculation, right? Fs, S is for shear stress, right? So determine the shear force acting on the key, and R is the radius, okay? So the only bit of confusion or doubts you might be arising is, how do we find this R, right? Okay, and keep thinking, or try to do your research on how do we determine torque, okay? When you say T is equal to F by R, F is the force, but this R here. So we know that F and R are perpendicular to each other, but where do we choose R, okay? Or what is the point of contact for R, right? So you'll be able to get your answers, okay? In any case, I will see this. I'm just going to assist with the assignment. I'll not be doing the assignment for you, right? I will not be giving you answers straight away, right? So I just help you out with this, okay? This is pretty much similar for all of you, okay? So, but for the calculations, I'll just give you the formulas. I'll try to explain what is going on, and the calculations you will need to attempt it by yourself. Okay, so it's 3 p.m. And I'll see how soon I can upload these all our this recording on Moodle. I'll just probably put it on YouTube and just give you a link if you like to go over this once more. So before I sign out, does anyone have any questions? Okay, you can feel free to speak so that others are aware and I can clarify it. Any questions, anyone? Oh, there's 8 of you still here. Let's see, Joel, Molly, Nitendran, Payal, Pravinesh, Ruben, and Sony. Does any one of you have any questions for me which I can address?
So we're pretty fine up till here. Understood well.
Yeah, I'd like to go very slow because, I mean, when this is due at the end of the semester, isn't it? Sometime in, when is the due date for this? I think it's given on Moodle. Is Moodle? Okay, assignment 2, submission box, only soft copy. Okay, it's due by 7th June, right? Okay, so most probably I'll take this week as well as next week, right? And you can always use the video recordings to go over it. I would really like you to understand this assignment, okay? Right, you might be able to find some solutions here and there, but it's always good to understand it once so that you're never forgetting it. Any case, right, so I'll leave you to it, okay? So have a good day, okay? And yes, when is the next one? So if you're able to, then make yourself available at on Friday, right? So 10 o'clock, 10 a.m. So that's when we'll have, I'll just continue from here. Okay, and if you come up with any questions, you can go ahead and start doing your calculations. Right, probably at the end, I'll try to finish early. And then if you have any questions regarding the calculations, use these slides, okay? They are really helpful. I will try to address them. Right, okay. That's all for today.
Thank you, sir.
That